All right, so this was a little bit more of a complicated question that was asked the other day in class. And what I want you to understand, at least for this year, this is not a mastery topic. We're not going to be mastering when we actually have both a horizontal compression, horizontal shift, and also a horizontal compression and a horizontal shift at the same time. So, but I'm still going to do it. Okay. So if I want to graph this, first of all, I want to break down what I know. So I know that the amplitude is going to be 5, right? I know that it seems to be shifted, right? There's a horizontal shift. Now, horizontal shifts are weird because it'll shift it, but it's also the amount of the shift is actually complicated by the speed, right? Or by that horizontal stretch compression. So I do know that it got, well, if it's 1/3 speed, it's really kind of like stretching out, right? So there's a horizontal stretch. And I also happen to know, because of that negative right there, that like my x values are getting made opposite. So I have this reflection over the y-axis, right? So I've got all of this stuff going on. Now, I can make sense of these things each independently, which we just did, and that's not so bad. But I think, and I don't like this axis, sorry. I think it might be helpful. Well, I guess I actually know one more thing too. I know that we are looking at the cosine function, which means traditionally it looks like this, right? Like that's the parent function. Now, the trouble is I've got to take every single one of those things and do it to the parent function. That's a lot of stuff. So maybe instead of trying to figure out what every single one of those things is doing and how it all gets manipulated, maybe I'm just going to point track. So I'm really going to track, where did that black point right there go? You know, that spot when the x was 0, because this was really the graph over here of y equals cosine of x. So this is really the spot when, like, you know, when that's 0, we get that point right there. So maybe I could figure out where that point went, right? So this is really about making use of structure here. So like when this thing is 0, okay, I get that point, right? And let's find a nice color. So when this thing is 0, I get that point. So when this thing is 0, I should get the same point. I should get the maximum point. So the question becomes, how can I make that yellow circle 0? Because if I can make the entire input for cosine to be 0, then I'm going to actually get that point, right? So I'm going to get the maximum point. I'm going to get the point that I'm used to, and then I can kind of trace my graph from there, you know? So the question becomes, where is that point? So what would make that yellow circle, all of that stuff in that yellow circle, right? What would make that become 0? And at this point in time, I can just solve, right? So I can go ahead and I can subtract, you know, pi over 2 from both sides. And then I'm going to get negative 1/3 equals negative pi over 2. And then I could just get rid of the negatives because it's like dividing both sides by negative. And then, forgot my x. And then I could multiply by 3 on both sides. And ultimately, in the end, I'm going to end up getting x equals positive 3 pi over 2. So that really means, you know, that somewhere over here on the right, let's say this is pi over 2, and this is pi, and this is 3 pi over 2, I'm going to get that point that we were interested in. Okay? That's going to, and I'll fill it in with yellow just so we can see that that's the point we're talking about. So it was here, and it actually got moved, which is weird because we thought it would be shifted to the left, you know, because of that plus right there. But it actually got shifted to the right, and the reason is because that reflected it too, right? So both of those things were happening. Now, I need to keep, you know, what do I know about, what else do I know? Well, I know that's where that one point is. But I know the amplitude got vertically stretched, so it's the maximum is at 5 and the minimum is at negative 5. So what else do I know? Well, I know it's still going to have the same basic shape, right? So I know it's going to look like this. The only thing is, I don't know how long a period is, because it got horizontally stretched, right? And since it's really 1/3 the speed, that's how I like to think about it, it's really 3 times as long, so the period here is going to be 6 pi. Now, if you didn't, you could always, make this procedural, like our period is 2 pi divided by that coefficient, right? But ultimately, we're going to see it's 6 pi. So, ooh, wow. So that's 3 pi over 2, 2 pi, 2.5 pi, 3 pi, 3.5 pi, 4 pi, 2 pi, 4 pi. Wow, it's gonna take a long time, right? So if a period is 6 pi, well then half a period is 3 pi, right? And then a quarter of a period would be 3/2 pi. So really, this 3/2 pi, because that's where this is, 3/2 pi, right? From 0 to there is a quarter period. So I'm actually going to see it come back to the midline right there. And then I could go, 3/2 pi more out, and I'm going to see it come back to the midline. And then, if I go 3/2 pi more out, I'm going to see it come down to the minimum. Right? And so we get this kind of elongated graph that looks like that. So anyway, like I said, this is not a mastery one. This is one of the more complicated ones, but this is a way to do it.